What we're going to do to start off with is just go through some basic background material. Some of you may have done it, others may not, but it'll be very good to have a good grasp of this as we go through the course. And if you don't know it now, or it seems hazy because it's a long time since you did it, just grab a basic book and go through this material in the first few days. Let me start with some basic microeconomics. We need to model how people behave to come up with financial models. And the methodology we're going to use is based on microeconomics. So you need to know this foundation of how we model behavior. And we're going to use indifference curves. And we've got a very simple case, for example, where somebody's trying to choose between apples and bananas. We can represent their preferences with a set of indifference curves. What exactly is an indifference curve? What does it measure? Yeah.
It's a set of combinations, in this case the two goods, which the consumer values the same.
Yeah. So it's a whole trade-off that the consumer has. As Ted said, it's bundles such that the person is indifferent, in other words, has the same utility or the same happiness from that set of combinations. So we have an indifferent curve like that, and so on. We assume usually that more is preferred to less, so utility is increasing in that northeasterly direction. So that's how we model people's preferences. And as I say, we're going to be using that a fair amount through the class in various different contexts. Now, in choosing how many apples and bananas to buy, we're constrained by a budget constraint. And what that says is that the amount you spend on apples, which is the price of apples, times the quantity of apples, plus the price you spend on, so amount you spend on bananas, which is the price of bananas PB, times the amount of bananas you buy, which is B, must be less than or equal to your income. Now we can rearrange this expression with equality to get the boundary, and what we get in that case is that A is equal to minus PB over PA times B plus I over PA. Now we can draw that on our diagram of apples and bananas. What does it represent? It's equation of a straight line. The intercept when B is equal to 0 is I over PA. And what's the slope?
Minus PB.
Yeah, it's minus PB over PA, which is this term here. And what we know is that the consumer has to be below it or on it. Now we can put the two together to find out what the consumer is going to do in terms of buying apples and bananas. So we've got a diagram. This is our budget constraint. It's an indifference curve. Can the consumer do better than that? Can they get a higher utility, a higher happiness?
We cannot go beyond the budget constraint.
They can't go beyond, so what's the best they can do?
Intersections.
Yeah, when it's tangential. So that's the point that maximizes utility. And that gives us the demand for apples and the demand for bananas. So we have a simple little model of what people buy. And we're going to do the same thing in a finance context. We're going to look at what kind of decisions are they going to make about saving and investment, portfolios, and so on. Any questions on the details of that? As I say, if that seems at all unfamiliar, then just spend some time with a basic micro textbook and check out how it works. Now, the second area that you need to know some very basic things is to do with future values and present values, which are one of the main foundations of finance. The basic idea behind these are very simple. Future values allow us to go forward in time. So if we've got, for example, one period or 1 year, and if we've got $1 that we put in the bank, then after a year, the value, which we call the future value, will be 1 times 1 plus the interest rate. Let's suppose the interest rate is 10%. Then what we're going to end up with is $1.1. Present value goes the other way. It goes backwards through time rather than forwards. And it says, what's the current equivalent of 1.1 a period from now? In other words, what would you have to put in the bank today to get 1.1 in the future? And rather than multiplying, what we do is divide, because if we invest this amount, 1.1 over 1 plus 0.10 in the bank, then we leave it there for a year, we multiply by the 1 plus 0.1, it cancels with that, and we're just left with 1.1. If you evaluate that, obviously it's 1. In general, if we've got C$1 a year from now, then the current equivalent of that is C1 over 1 plus R, where R is our discount rate or interest rate at the bank. If we have 2 periods, we can take the future value. If we put $1 in, after a year we've got 1 times 1 plus 0.1. If we leave it in for another year, we multiply by 1 plus 0.1 again, so it becomes 1 plus 0.1 squared, which is 1.21. Again, we can go backwards, we can go the other way, so the present value of 121 2 years from now, in other words, what you would have to put in to get 121 2 years from now to the bank, is 121 divided by 1 plus 0.1 squared. Again, that's 1, obviously. In general, if we've got a cash flow C2, 2 periods from now, the present value, the current equivalent, is C2 over 1 plus R squared. If we're working with T periods, it's going to be that the present value is CT, which is the cash flow at date T, divided by 1 plus R to the what? T. So we can always take a cash flow in the future and find what's the current equivalent of that. Any questions on that?